Let's work some more problems. So prove A or B and not B or C and not C, all that together implies A. So we have three hypotheses, A or B, not B implies C, and not C. So hypothesis, hypothesis, hypothesis. So what do we do now? So remember, I like to look at it and sort of work it in reverse. It's okay, here's an A, there's an A, but what do I do with that? Well, this has B, which is connected to this. Here's a not B, so somehow those are connected probably. This B has this C, here's not C, so those are probably connected. So what do we do? So it's probably going to start somewhere in here. Now if I look at my sheet of paper and say, okay, given what we have, if I think it probably involves these two, here I have a not B or C and then a not C. If I look at disjunctive syllogism, here I have a P or Q and not P, and it allows us to get Q from that. Well, they sort of seem related to what I just saw, except this has the thing that's being negated, the P here, as the first thing. Whereas for me, it's the second thing. So can we use that? Well, strictly speaking, sure, we could. Because I understand that really what that rule is telling me is that if you have either of these things that are ORed together, and then the negative of one of those, that allows you then just to get the other one out of it. But if you want to be really anal and match up with the pattern, which says, you know, this needs to be the thing that's first, then we would use commutativity to get that. So let's do that just to be really anal about it, to make sure the pattern matches exactly. So this means here this becomes C or not B. So that's, sorry, this right here should be this. I knew something was wrong. Should be that. So that was 2 and commutativity. Okay. And now I have those two. I can use 3 and 4 in disjunctive syllogism to get not B. And now I say I have not B, A or B. It's the same thing we just saw. To match the pattern on the sheet, the B needs to be the first thing. So I'm going to do B or A. So this is 1, commutativity. And now 5 and 6, and disjunctive syllogism allows me to get A from that. And so there's my final thing, which I have here. Okay, let's do another one. So prove not A or B negated and not C implies, sorry, not D. This is supposed to be a D. And A and not B implies D, and not C or E, all that together implies E. So this is much bigger than anything we've seen before. So let's write our hypotheses. Not A or B negated. Not C implies not D. A or not B implies D. And then not C or E. Hypothesis, 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 hypothesis. Start thinking what order to go in and look and go, well, here's E. Here's my only occurrence of E, so I'll probably use that close to the end. That has a C. Here's a C. That includes D. That has a D. This has A and B. This has an A and B in there somewhere. So it's probably the order I'm going in, or the reverse order. So let's start with this. This also says that one of the tips is De Morgan's, right? So I'll probably want to break this up anyway. So this becomes not A, not, and not B. So that's one via De Morgan's. And we'll simplify this. So this becomes A and not B. So that was double negation. So how can I use this A and not B? Well, here's an A and not B implies D. So I can get D from that. So that was 3 and 6. And modus ponens was the reason. There's a D. Where else do we have this? Well, we have not C and not D. So how do I put those together? Well, if I look at my sheet, this looks like maybe contraposition is what I could use. There might be other things, but this shows that P implies Q is equivalent to not Q implies not P. And remember, which one's written on the left, which one's written on the right, for these doesn't matter. These are equivalences. All right? So that means I can take number 2 here and rewrite it as D implies C. And this contraposition was the reason. And now it means that D and D implies C allows me to get C via modus ponens. So that's 7, 8. So there's C. Here's not C. And E. So once again, this is one of those judgment calls about how anal do you need to be. Well, here's disjunctive syllogism. This shows P and then not P over here. But I've got C and not C here. So let's think of it this way. If I were to let P equal not C, then C here, P prime, is that, right? So I'm just going to do that. So C not, which is equal to C. This uses 9 and double negation. And that allows me then to match the pattern exactly. So 10 and 4 allow me to get my E. So 4, 10 via disjunctive syllogism. So there we are. Took a lot of steps. Some of these you could have simplified, like, do you really need to go through this? Well, if you're being very mechanical or anal about it, then yeah, I guess you do. But strictly speaking, I understand really what it's saying, which is just that, when it says, is this right? Sorry, this should have been this. This should have been or to match what was here. When you have P or Q and not P, and use that to get or derive Q, it's really saying this is just the negated version of that. So if I had not A or B and A, well, that's easy to see. I just get B from that. But if you want to be anal, throw in this extra step. Okay? And if you're taking this course at a university and somebody's going to grade your problems, then you probably need to find out from them how specific they want to be. Do you really need to use commutativity to swap things to match? Do you need to always do this? Doing it probably won't hurt your grade. Leaving it out might hurt your grade, so you probably should check on that.